So the first person that's going to share with you is Dev Sinha. He's on the math faculty at University of Oregon. His specialty is topology. He works with Bill McCallum on the Illustrative math project. He writes comments on and edits the tasks. And this last summer, just this past summer, he led a work group. It was CCSS Math Learning Community, and it was a collaborative effort to involve K-12 teachers and higher ed instructors to look at Common Core problems, how to get deeper into the problems, and I think he'll probably talk a little bit more about that too. But thank you, Dev.
And thank you all, and I'd like to apologize for not sticking around. I missed all of week 2 because of a Smarter Balanced meeting inside a room like this all day, every day for 5 days, talking about achievement levels and things like that. So I can't say that I'm too sad to forego another opportunity to spend a day in a windowless room, but I am sad to thank you. To not further connect with the local community of math educators, which is one of the most meaningful parts of all of this to me. So these are some of the things that I've been involved in. It's a remarkable time in terms of the combination of mathematical and pedagogical work that's being done now. So some of you have seen this dog and pony before, but not everybody. But my apologies to some of them. I just want to talk about the Common Core through the lens of the Illustrative Math Project. They look a lot like other standards documents. There's actually some significant differences, especially when you dig down. I mean, really, what they are, I'm going to talk about through the lens of tasks, because that's what I've spent the most time thinking about, working on. But we shouldn't lose sight of the fact that what the Common Core is really about is a mathematical pedagogical framework to support best practices in teaching. These guys, when they wrote the document, the whatever 60 people in the room, really had teaching of folks like Deborah Ball in mind, and those kinds of teaching practices. But what do you need? What do you need to do to support that? And we'll talk about it a little bit. I mean, you need some coherence. You need some focus. But again, I'm going to come at it as a sort of a task-developing mathematician, and talk about it in terms of juicy problems. So what do I mean by that? I mean, it's just kind of a fun little piece of verbiage. Well, so here's what's not a juicy problem. If you're asking kids and you see exactly this, even in high quality, high performing countries, you look at Singapore math and you'll see problems exactly like this. 600s, 510s, 3 1s makes. And, you can do that without knowing much of anything. You can just learn what this problem is prompting me to do is take the first number and put it there, and the second number put it there, and the third number and put it there. Done. Next. Tell me what I should do next, right, is the standard reaction. At least, and again, you at least see, and it's not an unusual practice to see some problems like this, 3 1s and 500s. What does that make? You have to attend to some precision there in the ordering and that 0 that you need there. But even better is once you get to really knowing what 5 10s and 8 1s is about, and 5 10s and 9 1s. What about 5 10s and 10 1s? 5 10s and 12 1s. Okay? And we talk about coherence. This is not just a tricky problem. If you really can deal with 5 10s and 12 1s, then later in the day, not the day, but later in your school year, when you're adding 25 and 37, and you get exactly 5 10s and 12 1s, you're pretty well equipped. Right, so this is already how this juiciness serves this coherence and serves instruction that's well constructed. You can even make it juicier by adding some context where students have to kind of piece together what's going on. So if Mike works in the post office and you can think of these stamps as just kind of flat base 10 blocks, you've got these sheets which are 10 by 10 rows of 10 and strips and stamps. And Mike didn't have a lot to do at the post office that day, so he just counted every single one, and he had 4 sheets, 7 strips, and 2 stamps, and that matched. So why does that match? Okay, and there's one difference between even the first problem here. To really make a good explanation here, the students will have to say that, oh, the 10 strips of 10 on that sheet make 100. So there's something significant even that first bit. But in the second one, the next day he goes in, he finds 3 stamps, 1 sheet, 5 strips. He says that should be 315. Well, he's wrong. Why is he wrong? Okay, so that's a bit juicier. And then if you want to even have a second grade problem that is fun for adults, look, we're making things out of hundreds, tens, and ones. Can you, for example, make 124 out of hundreds, tens, and ones in all possible ways? That's the adult version. The kids, you say, well, try to make them in as many ways as you can. And if you think you've got them all, can you even say why? Which is probably not, you wouldn't expect an individual second grader to make this little picture of a partially ordered set and reason about that. But you could have some classroom discussion about being thorough, about the exchanges, and you can you see that you could actually get somewhere pretty interesting, actually, even for the very high performing ones, and even the ones who don't can at least get a much more significant sense for this flexibility. So I say juicy. The standards actually talk about the standards for mathematical practice. What those are about is really kind of being able to engage in more juicy tasks. Really, the other way around. The standards for the mathematical practices are kind of larger, and juicy tasks are meant to serve engaging students in those practices. Is what I should say more carefully. So what you're saying is it's about understanding, about really having some understanding there, probing that understanding with juicy tasks, developing that understanding with juicy tasks, and that there's some mathematical work being done. What is the mathematical work? What are they actually doing as budding mathematicians? Is it memorization? That's fine for a good part of what they need to do. Is that exclusively mathematical, what mathematical work constitutes? Absolutely not. So what is the mathematical work? Doesn't mean going fast, being really abstract, doing set theory, new math, doing exactly what they do in high achievement countries. Again, Singapore, at least the work books that I've looked at second grade actually don't have nearly as juicy place value problems. It does mean being more demanding, but being demanding in a way that, I don't know, my sense as an instructor, and also knowing some best practices out there, is being demanding in a way that students will respond as long as this consistently encountered at an appropriate level. So Common Core is really a 10, 20-year process, and hopefully in 10, 20 years we can look back and say, now we have these great curricula where these are juicy tasks, but there's just this one additional issue that students are working with at a time for a while, and then they're getting more sophisticated and things like that. I mean, if you, again, this mic task is not something you would jump into right away. You'd want some of the other problems first, and really, again, the first part of question 1 is recognizing that 10 tens is 100. So they should have seen that already. So you have to really think about, in incorporating juicy tasks, you really have to say, what's the classroom context? What do they know? Do they know enough? Maybe they know too much. If they know too much, it's not juicy. I see some tasks out there by very good places. I won't name because I generally like their tasks, so I don't want to be on video as poo-pooing their tasks. But I can tell from the student work that they already know a lot about the topic, and what looks like a really engaging task is probably not that rich for the students because they already have been given some big tool that they can hit it with. So sorry for being vague, but again, I want to be careful about disparaging others' work, which is generally really good and I admire. We probably will start seeing the achievement gap in more full relief. We already know, being at Lane and having this mixed audience, we already know that our high school teachers do a great job at what we're asking them to do isn't matching with the needs of the students in transition. So they pass their OAKs, and then they come here and then they don't place, right? That's the basic. Let's remind ourselves what some of the basic issues are that are getting us in this room and motivating reform, right? We are asking them to do X, and X is not getting them to where they need for their college instruction. And it's not about pointing fingers, right? Where whoever, I mean, this system has evolved over a long period of time, but I'm certainly not. I absolutely don't want to point fingers at the high school teachers. Say, if you were doing a better job, they would be placing into Math 111 consistently. No, I don't believe that. I see what is out there in terms of curricula, and I see how that's not serving them well. So maybe I'm pointing fingers at the curricula people, but it's all, you talk to them and they're like, well, we're giving the states and teachers what they want. And you talk to the assessment people, and we're giving the states. Anyways, let's not play the blame game. Let's just recognize that we should and can do a lot better. And that's part of the context that the Common Core that is the main context that the Common Core sort of came into being. And a lot of the process that I want to emphasize is having the math and the pedagogy validated by teams of mathematicians and teachers. That's for the Common Core itself. That's been for Illustrative Mathematics. That's continued for the assessment consortia are working under such a model. I would hope that Curricula PD also continue to have those partnerships. I'll talk about that was a big component of what some of us did around here this summer. You look at mathematics education research, what high-performing countries do, and just professional judgment. The Common Core has a very large bibliography, right? You look at those papers if you really want to understand the basis for some of the bases for the choices made, but other bases are made just because you're really thinking about reasoning. We want them to reason about adding fractions. Well, the best place to do that is on the number line. Oh, our second grade teachers better emphasize addition on the number line then, right? This is a third and fourth grade really topic, but we choose that second grade model based on that fourth grade topic. So there's a lot that goes into it, but again, if you don't have this combined eye and sense of the mathematicians and the teachers together, you're going to miss those opportunities to set things and really encourage the kind of reasoning and conceptual understanding. So you want to prioritize depth and focus then, okay? That was really about it. And I think a lot of high school teachers look at the standards and validly say, I see the focus in K through 8, I don't see it in the high school standards. And, I'm not going to get into that so much, except to point out, I want to take the opportunity to point out that there are documents which kind of elaborate on how there is focus, or there's at least focus intended, if not immediately they're hitting you in the face at the high school level. So let me go to the first document here, first tab. So Jason Zimba, one of the lead writers, put out this priorities document, and won't go through it, but as you get into the standards, green square means emphasize, focus on, okay? And the lower grades, so this is grade 2, it's a lot of green squares, right? And then the others are, I mainly think in terms of green squares, not green squares. And still through grade 6, yeah, mostly green squares. Grade 7, yeah, a lot of green squares. What happens in high school? Fair number of green squares in functions. What happens in geometry? What happens in statistics probability? What happens back in the numbers and quantities? 1 green square. So, the standards are this framework, but I say this more to hopefully put high school teachers a bit at ease and say, yes, you are meant to focus too. And hopefully if the curriculum writers and assessment writers, et cetera, do their jobs, they'll get this message, and Jason and others have put it out elsewhere, and you'll see it. The other place where you can see the focus a bit, and I like the green squares better because you can just see that immediately. I'm not okay. Is the content specs for the Smarter Balance assessment. And again, if you just, it's harder to see immediately that the focus is there, but in the content specs itself, up here, there's a lot in this document, so it's hard to even get to, because they have some examples. These targets that they name, if you look at the targets that they name, and they also have this M is a main target, but then there's also AS for something in supporting. So those M's are, as high school teachers, what you want to take to heart as, okay, the Smarter Balanced Assessment is going to really emphasize those M's. Okay, so that's just, I think that's important. If that's really, you know, the Common Core is supposed to be addressing this mile wide, inch deep phenomena, which is one of the main ones that's been consistently brought out in studies about sort of why we don't perform well relative to a lot of other countries, and it's not meant to continue in high school either, even though some readings of the high school standard would indicate that that's not the case. So again, I'm a task writer by trade these days. In part, I wanted to talk about this this notion of juiciness, this notion of being more engaging, just to get. I think it's important as educators to develop a vocabulary around these. And then this is also how I'll show you bits of the Illustrative Mathematics project. So one source of juiciness, and this will be something that Smarter Balanced is doing more than the other assessment consortium, PARC, is having more modeling. So real world, and it doesn't mean a word problem that when you read it you can take whatever equations you're solving or something in the body of the text, figure out how the numbers in the word problem plug into that equation and turn it. That is not modeling. Modeling means actually trying to make sense of something, and hopefully you'll see some examples if you look at the Smarter Balanced items. I won't go through that so much, but I will take you through some illustrative math modeling problems, give you a look. So here's one on mixing fertilizer. Mixture A has 5 liters of liquid fertilizer, 50 liters water. What's the concentration? So you go through the numbers first. The point of this task is to really connect the algebraic expressions with the numerical. Notice that you've got this funny name for a volume of water, F sub A. In college readiness, that's something us faculty would like is students just to be comfortable with expressions like F sub A over F sub A plus W. Take the time to really go through this in numbers, and so to understand why adding here the main point is to understand in both numbers and variables why doubling the amount of liquid fertilizer in the same batch of water doesn't exactly double the concentration. So you see that in parts A and B, and you also then see that algebraically in the second part. Okay? So, but you've got this context around, this modeling context. I mean, this may be less so than others. Fixing the furnace I like a lot. This is an 8th grade task. By content, I would say it would be a very good Smarter Balanced high school task. Actually, you'll see some things. This is our economist friends would say it's a fixed cost and marginal cost kind of analysis. So I guarantee you that and I've talked to them about it, that if we can actually have our high school students address questions like these, our economists in departments here and around the country will jump up and down. They'll say, all right, this is great. They understand the math that you need. So if you've got your furnace repair coming out, and either some service fee for coming out and a smaller per hour additional, or no service fee for coming out, and you want to just know, okay, which is going to be the better deal depending on where I'm at. And the nice thing about that problem, it's a problem that I think is engaging. And notice that at the end of the day, the mathematics actually, if you look at all those linear functions, it's something that is a much at a much greater level of complexity than we tend to do with linear functions. Okay, so but the modeling allows you to sort of be more complex and sometimes also more reflective than otherwise. Yeah, here's a simple growing coffee. Again, you're pulling out some real numbers. Oops. Let's see. So that's. So what are some other ways that we see some juiciness? You really want to connect procedural and conceptual in a Common Core aligned instruction. The circle and the line problem is one I like a lot. You look at this circle, the standard unit circle, and the line y equals 2x minus 1. You first graph them and just notice that there is a root that looks like it's there by the graph. Of course, that's not enough to know that it's there. So the first part is to actually, connect that conjecture that you immediately make that there's a root there to actually knowing that there's a root by plugging in. So that meaning of intersection, sorry, not root, but intersection, that meaning of intersection by checking. And then you follow up and you say, okay, there's another one over here. Can we find that? Can we find this other intersection point? And then you're doing this algebraic manipulation. But you're doing it, you've got one problem context that's engaging both all three. Graphical, it means what an intersection means. It's a solution to both. And the algebraic approach to finding it. So it's very consciously engaging multiple ways of, in this case, approaching just the simple intersections between a circle. Huh? The circle and the line in A-REI. So in fact, let me show you.
Do you have to log in order to see these tasks?
So I get to go through them kind of in shorthand. In order to see these tasks, you don't have to log in, but you would have to go through high school standards, and the intention is to illustrate the standards. So unlike what I'm doing for you now, just taking one through the other for the purposes of my presentation, in general, you go, let's see, what was that? Was that an REI one? Reasoning with equations and inequalities. And coming here, I think this laptop knows that I'm a Mac person, so it's just not. Oh no, not radical. So anyway, that's how you need to go through most of them. Okay, and yeah. So yeah, you have to drill down. It's again meant to illustrate the standards, not be a problem bank, as I'm kind of going through now. Let's see. So how does the solution change is another connecting process and conceptual. You can also connect different approaches or representations. Another one of my favorites is seeing dots here. So we again are familiar with being able to teach students how to take n plus 2 squared minus 4 and convert that to n squared plus 4n. We might say simplify. Actually, the word simplify algebraic expressions is not in the Common Core because you don't always want to simplify. So the idea is to find equivalent expressions, which in some cases you do want to have this standard ax squared plus bx plus c form, but in others it's better to, for example, complete the square. This first way to see this expression lets you know that this would have minimum at -4. Namely when n is -2. So sometimes I might take this expression and want to produce this one. In any case, in this task, you want to get both a geometric and an algebraic reasoning for that. And the algebraic one is, of course, what we usually emphasize, but you can also just count the dots. We see, on the one hand, this square would have, if n is the number of middle dots there, so here's 1, 2, 3, then this square has n plus 2 squared dots total, but 4 are removed, and that's the first expression. On the other hand, I can say there's that n dots there, n squared dots in the middle, and then n dots around each edge, and that's n squared plus 4n. Okay? But it's very consciously demanding or encouraging a connection between some algebraic reasoning and some other kind of reasoning. So algebra isn't the separate thing you do in a silo. Algebra interfaces, in this case, with just simple counting. Okay? Some other things to think about, and the nice thing is it's fun to really start being a part of a community. And again, for me, it's especially fun to be part of a sort of joint K through 12 higher ed community where you start discussing some of these. What makes this a good test? What makes this a juicy test? What makes it maybe not so good? What's going on here? What are we demanding of the students? Explanation is one of them, and we're used to maybe, we think of that as why we have proof in high school geometry, although I think I showed you that the high school geometry probably won't play as large a role in, like, for example, the smarter balance assessments, so that's something to figure out. But reasoning is now supposed to be throughout, and you can ask for full-out explanations, even some proofs at the high school level. But let me point out that just it's this judo almost, where just a little bit of rephrasing gets something from a kind of procedure to more of an explanation. So the physics professor is a nice one in that way. Oh wait, where is the physics professor? There. The physics professor says, of course it's easy to see that L naught times the square root of 1 minus v squared over c squared is 0 and v equals c. Give a possible explanation in terms of the structure of the expression why the professor might say, of course. Okay? So it's an explanation being demanded. It's different than saying, well, show that when v equals c, this is 0. It's sort of going through what it's trying to prompt is going through that expression carefully and saying, well, when v is c, we see that v squared over c squared is 1, 1 minus 1 is 0, the square root of 0 is 0. It's asking you to take that apart rather than think of that as a single calculation. And this is shaded between calculation and explanation. I'm not saying this is the ultimate kind of explanation we want, but just to understand there's this continuum of what we might think of as explanation, and just by a little bit of shading you get more of that. You get them used to saying, okay, well, what's going through here, and being a little more systematic. And then let's see what else I had here. Throwing horseshoes. Oops. See there. So again, which is the most useful in finding the maximum height of the horseshoe? So it's a bit different than actually just asking what is the maximum height, which we'd usually do. You've got all these expressions. Wait, one is more useful, okay? And then explain, okay? And this actually asking some reflection that you don't get by just saying, what is the maximum height? And then, okay, we'll go through and put it in, complete the square form, and then we see that. What else do I want to say? I want to probably, yes?
I was wondering if you can share briefly from the perspective of a smart balanced writer.
So I'm not a smarter balanced writer. I went to
The illustrative math.
yeah, I am an illustrative math writer, yeah.
Perspective on the usage of calculators, particularly the elementary grade.
Well, so one of the mathematical practices is using appropriate tools, and yeah, you certainly can see some tasks where it's appropriate and some not. I know on Smarter Balanced they won't allow calculators on 3rd and 5th grade. They'll start allowing them on 8th grade. When I write tasks, one task that's under development, let me show you here, exactly gets at some of that. So again, this is not on the site. This is one that, and by the way, my name won't be on there. Everything's kind of anonymous. Everything's due to the group, but I knew about this one because I just wrote it. So Alicia and Zara are working together as scientists. Alicia finds that 3 to the 1.4 is 6.218. Zara thinks and says, that can't be right. 3 to the 1.4 must be less than 6. Find some hand calculations, or maybe I should say simple calculations, simple arithmetic calculations that show that 3 to the 1.4 must be less than 6. And here's the solution. Because 1.4 is less than 1.5, then 3 to the 1.4 is less than 3 to the 3 halves. That's the square root of 27, and that's less than the square root of 36. So here, you could see this actually being appropriate for a calculator with just plus minus times. Similar for a task which says let's place square root of 28 on the number line. These are middle school tasks more, but where okay, maybe you've got your calculator which helps you. Let's even think, why is square root of 2 between 1.4 and 1.5, or 1.41 and 1.42? Well, 1.4 squared is whatever it is, 1.96, and 1.5 squared is 2.25, and that's why. So you could see calculator being an appropriate tool because then it makes it easier for them to actually do that reasoning. They're not stuck on that long arithmetic and kind of get lost in the weeds, and you think of your classroom time and how valuable that is. And sure, letting them in as 8th graders use a calculator to get 1.4 squared or 14 squared, that's fine. On the other hand, if we just said calculator however you want to use it, that task completely falls apart. So it really goes for me, it goes from task to task. And sometimes they're designed to have a little technology support, but sometimes no technology at all. Sometimes you say you kind of limit it. Smarter Balance by being an online adaptive, by being online, they could supply a rudimentary calculator for some. So you've got your calculator there, but you can only do plus, minus, and times when you'd really love to have a square root function, but that's what the thing is getting at. So use appropriate tools, use tools appropriately. So that gives you some idea of what's on Illustrative Math. Again, it's a little bit, I took you through it in a way that you can't kind of navigate the site yourself. Let me talk a little bit about our PD model, because I think this is something that's worth going further with, is actually and especially this was K through 12, and there's different benefits you would expect for different groups, but the idea was to look together. A lot of the tasks I've given you to understand their value, a lot of the classroom situations you're looking at to understand what's going on, you need both a pedagogical and mathematical perspective. A simple one is a student struggling with topic X, and one of the main things that we need teachers to really understand is everything that goes into X to deal with it. And so the model was to have a bit of higher ed presence around, grad students, instructors, some undergrads, some really good undergrads that we have around, to look at problems at the same time and have those discussions together. Because again, the higher ed folks really spend their lots of their lives thinking about how this mathematics fits together. And that's one of many things that the teachers need to think about. So to have those conversations. So it seemed like that was pretty worthwhile. I think there's a lot to be done to make that a viable model at scale. I think you have to think of the right questions to be looking at together But again, my experience with illustrative math is it's a lot of fun to actually talk through some of these classroom pedagogical mathematical issues that all are entangled, and to have different people say, oh, okay, well, here's the way you can get the mathematical reasoning here, and the teacher say, okay, here's where they actually have the most trouble, and the mathematician say, oh, that's interesting, that's because of this fact. And so to have PD as this kind of conversation is part of this model, and I'm happy to present to this group because it's, of course, very well along the same flavor. So I'll stop there.